Okay, so in this video, we will see the next coding problem. So the next coding problem, so if you open the Leetcode and in the search here, search the problem move zeros. So this is also like important questions and come under the easy category only. So if you open it, so problem number 283, move zero. So what the problem is, given an integer array nums. So let's remove this. So the problem say given an integer array nums, move all zero to the end of it while maintaining the relative order to all the non-zero elements. Okay, so what the problem is? So let's suppose you have an input array. So any input array which is a combination of like zero and non-zero elements. So any number of zero or any number of non-zero elements, right? So you have to move the zeros at the end. So you have to move the zeros at the end, but without while maintaining the relative order. While maintaining the relative order means so 1, 3, 12 should be remain in the same order. Like output should be 1, 3, 3, 12, 0, and 0. It doesn't mean like the output should be 1, then 12, then 3. If the output is 1, then 12 and 3, or 12, 1, 3, or 12, 3, 1, then it is not maintaining the order. So 1 comes before 3 and 3 comes before 12. So in the output sequence, 1 comes before 3 and 3 comes before 12. But all the zeros should be at the end. All right. So, and here in this question, it is mentioned, note that you must do this in place without making a copy of an error. So just ignore for the time being this line. So if we see this question, by looking the question, it looks like very easy. We have to move the zero at the end. So what we will do, we will run a loop. We will see, okay, this is the non-zero element, and we will insert in some array. Then another non-zero element, we will insert into that element. Then another non-zero element, we will insert into that element. And then we will like insert the remaining zeros. All right. So let's try that method. So basically what we are doing, that is the brute force method. So we will create some another array, temporary array. So as an example, so we created some temporary array, maybe temp. All right. Then we will run a loop on the input array, and we will append the all the non-zero elements. So loop will run from here to 0 to 12. So first 0. So 0 is non-zero, no. Then 1. 1 is non-zero, yes. So we will append the 1 into the temp. Then 0. So we will ignore this. Then 3. Then we will going to append. Then 12. Then we are going to append. So that's it. That's the end of the loop. So we have 1, 3, 12. But the output should be 1, 3, 12, 0, and 0. So this array has 3 elements. The original array has 5 elements. So how many less elements in this array? So 2. Then we can run a loop 2 times. All right. 2 times means length of this array, length of the input array, and length of the temporary array. And we will append the remaining zeros. So if that is, we have to append 1, 3, 12, and we have to append the remaining zeros in that. So this solution is perfectly fine, not an issue. Even we are running on a single loop, that is O of n. But here in this problem, we are using some extra space. But it is mentioned we should not use the extra space. But anyhow, first we will implement this approach. Whether we will able to implement this or not, then first we will apply this approach, right? So problem is, so let's copy this code. And this is like typing module. So from typing import list, let's remove this. So this is the, you can say, brute force method. Okay, so let's create some array. Let's use this example only. We have this example, and then so let's do some spaces. Okay, and then we will going to print solution dot move, and we have to pass the then print. Fine. So what we have to do? We have to create some array, that is the output array, okay, which should be empty. Then we will run a loop for x in numbers. Like for we will going to run a loop on this number, and if we find the non-zero element, we are going to append it. So if x not equal to 0, that is the non-zero element. So if it is non-zero, we have to append into output array. So x is going to append. So if we print it, print output, and if we run it, I can move zeros. So 1 3 12, 1 3 12 is the output, but we need 1 3 12 0 0. So what we have to do, we have to append two more. So basically we have to run the loop for dash in range, or you can say for I in range. We have to run the two times loop, but we can't hard code it, right? So what is two? We can say that okay, the number is some number n, and what we have to do, we have to append the zero. We have to append the zero. All right. So there is no use of I, so we can remove that variable and we can use the underscore. Along with that, what is n? So n is length of nums minus length of output. So output. And we are going to return our output array, because only like in our original element we have, let's suppose, 5 elements. In the output element, the non-zero element is 3. So the remaining two elements are there, 0, and we know the remaining two elements are like 0 only. So we are going to append it. So let's run that. So now we could see our output is correct, 1 3 12 0 0. All right. So that is perfectly working fine. So not an issue, like which is like a normal approach. But in the question, if they have not mentioned like you can't use the some extra space, all right, then we will go with this approach only. But in generally, like in the interviewer will tell you don't use some extra space, don't use some for loops, some extra loops. But anyhow, we are using only one loop. So time, for the time complexity there is no issue, but for the space complexity there is an issue, because we are using some extra space of n. For time complexity there is no issue, right? So let's try some another method. So move zeros, second method. And but anyhow, like we have mentioned none here, and here we are returning some output. So we can mention here list of int that is returning. But here, like we don't need to return anything because it will automatically check. All right. So because here in the question it is mentioned like we need to do in place. In place means we need to update only this array. So we don't need to return anything. If we replace this array itself, then we don't need to return anything. So what's the like next method? Like so the next, like there are two more methods. So first method like come into my like in our mind is, or my mind is, like we don't have to use the extra space. All right. So the same way, like we have to run some loop. Definitely we have to run one loop at least, because we have to access the element. If we have to access the element, definitely there should be one for loop. All right. So we can take two variables. One is left, one is right. Right. And both the variables on the zero. On the zero means the first index, that is the zero index. So what we can do is we can check if the, let's suppose in this case, so both elements are zero, right? So we can't do anything, like if we replace L or R, like there is no use, right? So what we can do is we can increase our right element. So now left is, so here, so if left is 0, right is 0, then we are going to increase our right index. So right index will be on the index number 1. So now the left index is on 0, right index is on 1. If left index is 0 and right index is not equal to 0, then we are going to replace, because we need to move zeros backward, like we have to move zeros. So if left is non-zero and right, if left is 0, right is non-zero, then we are going to swap both elements. So we have swapped both elements, so 1 0 0 3 12, right? And as soon as we swap, so now we are sure on the left index there are non-zero elements, so we will increase our pointer, left pointer. So now we have the left pointer here. Now again we are going to check left and right, so it's both are 0, so no need to do. We will increase our right pointer, because if both are 0, then we increase our right pointer. So we increase our right pointer. Now right is here. Now both are 0, again we are going to increase our right pointer. Now the right pointer has non-zero, so we are going to replace. So now we are sure, like on the left pointer it is non-zero, then we are going to increase our left pointer only. So now both are 0. So if the left and right pointer is 0, we are going to increase our right pointer. So this is like repeated. So now the left is here, right is here. So now the right pointer has non-zero and the left pointer is 0. So we are going to swap it. So if we are going to swap it, and then we have to increment our left pointer. Now both are 0. So we will in if both are 0, we can increment our right pointer. So as soon as we increment our right pointer, so if both are 0, we have to increment our right pointer. So right pointer go outside the array. So we have to stop. So when we have to stop, when the right pointer goes out of the array or left pointer exceeds the right array, then we have to stop. So let's implement that. So let's try to implement this the second logic, which is some which is not using the extra space. All right. So we figure it out our an algo what we have to write. So let's try. So we know we need two pointers. One is left pointer and one is right pointer, and starting index for both should be 0. All right. And there are three conditions. There are three conditions. So if both left and right will be 0, then we will increase the right pointer by 1. So let's write that. If left is equal to 0 and right is equal to 0, then we have to increase our right pointer. Right is equal to right plus 1. Okay. Elif. What is the second condition? Second condition is, if left is equal to 0 and right is not equal to 0, then we are going to swap it. So if left is equal to 0 and right not equal to 0, so we know right is not 0, but left is 0. So, and we want the 0 on the right hand side. So we are going to swap it. So nums of left, and we know how to swap it in a single line. Nums of right is equal to nums of right and nums of left. Along with that, now on the left position, we know it's already the non-zero element. So we are going to increase our left element, left plus 1. Right? So left is equal to left plus 1. So that is fine. And what else left? So there is a one condition left. So let's suppose if our array has like this. So let me take some input array. Our array is like this: 1 1 1 1 1 0 1. So now left is here, right is here. So both are non-zero. All right. So what we have to do? We know both are non-zero. So we are going to increase the both. All right. So otherwise, when both are non-zero, we are increase the both. Left is equal to left plus 1. Right is equal to right plus 1. And let's return the nums. So here in this question, we are doing the we are not using the extra space. So let's try if it's work fine or not. Rent Okay, it's not working fine. It's like first one is like perfectly working fine, but the another one is not working fine. So 0 1 0 3 12. So nothing is working. So why it is not working? So okay, we are not running a loop. So like we have to run this logic in some loop, right? So these are the condition, but we know we have to run the loop till the end. So when the left index is less than equal to and or right index is less than equal to length of nums, till that point we are going to run this loop. Okay, 1 0 0 3 12, still it is not right. So only the first index is going to like so let's see like what's wrong in our like code. So as per the question, like we have to move the zero at the end. So left and right both are on the first index zero, right? So we are going to increase our right pointer. So right will come here. Then we see okay, right has non-zero, then we are going to swap it. So if both are non-zero, then we have to increase our right pointer. So that is fine. Left is less than equal to right, and right is less than is equal to length of nums. So both conditions are true. So if left is equal to 0, right is equal to 0, right is equal to right plus 1. So perfectly okay. And if left is equal to 0, left is equal to 0, and right not equal to 0, left is equal to 0, and right not equal to 0. So what we have to do is nums of left, nums of right, nums of right, nums of left. So we are going to swap both the elements. So we are going to swap both the elements, and after swapping, we know at the left position it's 1. So left and right will come here, right? So L and R here. And so left will be increasing. Otherwise, we are going to increase both the elements. So that is perfectly okay. So what's the issue? Control J, let me comment this. 1003. Let me see like what's the issue. Okay, so this is the issue. We are checking the left, but we have to check the element. So how to check the element? Nums of left, nums of right, right? So that was our mistake. Nums of left, nums of right. Because basically we have to check the element, whether the element is zero or not zero. So let's try. So now it's working fine. So let's submit this solution, and we'll see like if it like clear all the test cases or not. So let's remove this. So let's run it. Okay, accepted. So let's submit it. So it's accepted, and we could see we have beat 68.61% in the memory as well. But is there any other solution? Like because in the description, if you see, there is a follow-up question. Could you minimize the total number of operations done? So can we minimize the number of, because here we are performing so many operations. So that is perfectly fine, even it is being like accepted as well. So, but is there any other solution? So yes, there is one more solution. So the more or less same solution, like not any extra thing. So what we are doing is again we need two pointer, because if we have to run only single loop and we don't need extra array, then in every question we need two pointers. So what we can do is, because we know we need non-zero elements at the starting index, right? So what we can do, we can run a loop sorry. So what we can do, we can run a loop from starting to end, and as soon as we find the non-zero element, we will put on the front. As an example, we will take two elements. So I on the starting index, j on the starting index. So we are running a loop. So first j is on 0. So is it non-zero element? No. Is it non-zero element? No. So it will go to the loop will do nothing. So then it will go to the next element. Now j is non-zero. Yes. So we are putting one here. We are not swapping it. Earlier we are swapping it. So in this case we are not swapping it. So j is here. So if we are not swapping it, output should be 1 1 0 3 12, because we are putting one here and j is 1, right? And then it will go further and it will check for 0. So it is 0. So which is zero element. So we don't need to touch it because we want non-zero elements only. And I will be here because if we put one here, then we have to increase the I as well. So I will be here and j will be here. So then it is like a 0. It is not non-zero. So we are checking the next element. So 3 3. So it is non-zero. Yes, it is non-zero. Then we are put 3 here. So similarly, we run a loop. So at the end we get this array like 1 3 12 3 12, because after the end we are getting because we are not swapping. If we are not swapping, then like how the 0 will become. So the remaining element will remain as it is. So 3 and 12 will remain as it is. So we know our I index on the our I pointer is on the index number 3. So 0 1 2 3. And we know the length of our array is 5. So 5 minus 3 is 2. Then we are going to append two zeros, or assign two zeros on this point, on this location. So more or less it's the same only, but anyhow it's a combination of both. So let's try to implement this as well. Even this is also working fine. So let's try to implement that, because here we are also using the two pointers, but here the number of operations are some more. So but in this some number operation will be some less. So let's suppose I and 0. So what so I only 0. So only one pointer. So we have to run a loop for j in nums, right? So for j in nums, so it will run a loop from 0 to 12. As soon as we found a non-zero element, so if j not equal to 0, as soon as we found non-zero element, so first here it will do nothing. So first j is at 0, it will do nothing. Then j will at here. I is not going to change. I is still 0, but j is at 1. So if j is 1, we are putting at ith index the jth element. So nums of I equal to j, and we will increase the I as well, I plus 1, right? So nums of I at j means like what it will become: 1 1 0 3 12. So this will become like this only. And if I print nums, just to show you, and let me print the third. So third method, if I print nums, so you see the output is 1 3 12 3 12, but we need two zeros. And if I print I as well, where is my I index? Because I will move only, so I is at 3 index. So we know I is at 3. So I need to one loop for I in range. So from which position I need to run? From I position till which position? Length of nums. Not length of num. So we are calculating the n, because length of num is going to change again and again. Length of nums till n. and we are putting for x, and we are putting 0. So I is 3 for from third index to fifth index. Length is 6. So till fifth index. So from third to fifth, we are replacing the element. We are like assigning the variable 0. So if you run this, so now we are getting, okay, we are not returning nums. So let's return nums. So we are getting 1, 3, 12, 3, and 0. And if we run this solution, so like, is there any time increase or decrease? So let's see. Run, submit. So even like memory look less 97, but like time looks more, like more or less like same only. Like I can't say like it's taking less time or more time. So more or less same only. So we can use like any method. So in the first method, what we see is that in the brute force method, we take some another array, we run a loop. Whenever we find non-zero element, we are going to append. Then whatever the remaining elements, we just append the 0. In the second element, in the second like method, we know we don't have to use the extra space. So we take two index left and right. As soon as like, because we know when we have to replace, when the left is 0 but right is not 0, then we have to replace, otherwise we will increase the pointer. That's it. So we will go to this condition. If left is 0, if left is 0 and right is not 0, then we are going to like swap. And as soon as we swap, then we know at the left it is non-zero, then we are going to increase the left. But if we are not swapping, it means left still 0, so we are going to increase our r pointer. And like if both are like a non-zero, then we are increasing both the pointers. And in this case, still we are using the 2 pointers only. But in this case, we are like running one loop, and as soon as we find the non-zero element, we are like putting at the ith index, and we are increasing I. And whatever the position at the last, the ith index, then we are like putting the number of zeros, the remaining number of zeros. So both are like same only, like any approach we can follow, and both are taking more or less same time only, and both solutions are accepted. So that's it. That's, you can also try this question. Like this is come under the easy, and it's a move 0. So move zeros, move ones. So this question can be modified in two ways. Move all the zeros, move all the ones, move all zero front, move all ones at the end. So just try that. So thank you.